Hi everyone, today we're going to be looking at the EasyPLC Simulator Robotic Cell Click PLC. Now the Machine Simulator, or MS, is part of the EasyPLC software suite. It has many built-in machines that are used to show different programming techniques. The Robotic Cell example is one of these machines. This will demonstrate a sequencer example. The logic will step through different steps in order to perform the task. In this case, an engine is lifted and placed onto a rack. We will be using a Click PLUS PLC and the Click programming software to program the EasyPLC Machine Simulator engine loader of the robotic cell. This will be done using Modbus TCP or Ethernet for communications. The program will allow you to start, stop, and jog the sequencer. Using the 5 steps for programming development, we will show how the sequencer is programmed. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So the first step in programming our EasyPLC Robotic Cell is to define the task. So if we go to our Machine Simulator, we can hit Start, and under Start we will see the engine loading. If we click on it, we will see a description of what actually has to happen, and using the industrial robot to load the engine blocks in the pallets, manage the conveyor stops to place the parts in their position, and the robot to load the engine back into the pallet. Once loaded, release the pallet, and the robot moves with the PLC digital input and output signals. And it does show you the inputs and outputs that are required. Now, in order to demonstrate that, we can actually go into demo mode. And in demo mode, this will load up and actually run the program for us to actually see the operation that needs to happen. So once this is loaded, it will actually then start the program itself. Here we go. So here you can see that we are in demo mode here. You can see the engine being released and the pallet being released, and the 2 stoppers, one here and one here. Once the engine's here, we have the robot come down, pick up the engine, and carry it over to where the pallet is. Once it's stopped, it then places it down and releases the engine into the pallet. Then the engine gets released down the conveyor belt and the operation starts again. We can also speed this up by looking at the time sequence. Just be at 3 times, just to show you the basic operation of this unit. So that is what has to happen. Now the next step in our 5-step process is to find the inputs and outputs. That's step 2 of our EasyPLC Robotic Cell. And in order to do that, we can look at View I/O. And here on the View I/O, we can actually see the inputs and outputs as we go along. So here is our digital outputs. So this is what the PLC will be controlling. And we have our conveyor advance, and we have our stop 1 right here. We have our robot fix part, which actually picks it up. We have our stop 2. Then we have our positioning for our robot. Now once we hit the position, it will continue until we get our input signal robot stopped, and that's robot stop will be for the movement. Then we have our engine create and our pallet create. Then we have our beacon light for the red, yellow, and green. Over our input side, we have our robot detect, we have our robot stop, which is the motion as I mentioned before, and then we have our 2 inductive proximity switches that are located with the stoppers. So when that pallet and that engine stop, it will trigger those inputs to operate. So that is our inputs and outputs. And what we can do is we will just exit out of this demo mode. And to fully understand the inputs and outputs, we can go back into the machines. We will select engine loading and we'll hit start this time. Under start, we don't have any control whatsoever. So what you'll see is we have our no PLC connected, and we can look at the View I/O, and under View I/O we can actually toggle this. So if we want to start the conveyors, we can hit start conveyors, and the conveyors are now started. You can see where stop 1 is, We can lift that up, turn that on, which is located right here, and then we turn that off. So here we can, there's stop 2. So here what we can do is actually try the program itself. You can see here that my robot has stopped. We will go to the take part position, and it will go down, and then the robot stops. We can then go lift part, and you can see the lift part picks it up and moves it over. You can hit load part, and then we can say elevate robot. So these are all the different, and then robot home. So again, we can make sure that we fully understand what all of the inputs and outputs are actually doing as we go step through it manually. So that is our inputs and outputs for the EasyPLC Robotic Cell. Next is the step 3 of our EasyPLC Robot Cell, which is develop the logical sequence of operation. Now this is where you're going to spend most of your time. And a flowchart or sequence table is used to fully understand the process that needs to be controlled. It must also answer things like what happens when electrical power and or the pneumatic power or air is lost, what happens when the inputs and outputs fail, do we need redundancy? Questions like that must be answered. This, like I said, this step is where you're going to spend most of your time. Understanding everything about the operation will save you time. It will help prevent you from continuously rewriting your PLC program logic. Knowing all of these answers up front is vital in the development of the PLC program. The sequence operation comes down to using indirect addressing pointers in the PLC. Now, here is a sequence table for the robotic cell. Now, if the input conditions are met, then the outputs are set, and the next input conditions are looked at. And if they are equal, then the next outputs are set. This will continuously cycle through the table. So, as you see here, I have all of my inputs. So, robotic cell working, my robotic detect part, my inductive switches, and then I put a robotic cell run and a time delay just between a couple of different units. And then our outputs, we have our conveyor, our 2 stops, our fix, we have our robot movement commands, we have our work engine create, and our pallet create, we have our beacon light, and then we have our time delay so we can control this. So the first thing we do is we put those outputs on, and then look for that next input. If these input signals are on, then the next output sequence comes on. Now, we've also addressed this in our DS, which is part of our Click PLC program, and where these addresses are coming from. So that is fully part of your developing of the logical sequence of operation. Now, once you have that down, then what we will do is then actually do the development of the Click PLC program, which is step number 4 of our EasyPLC Robotic Cell. So we'll just pull up the Click programming software. Here it is right here. And just to let you know, we do have our Click currently running, and we'll show you the actual hardware we have here. This is my Click PLUS PLC. And you can see we are communicating through our Ethernet port located right here. And we have one output card here, and our internal I/O are actually going to be operating this EasyPLC simulator for the engine loader. So what we'll do first of all is take a look at our port settings. So if we go into the setup mode, and we can look at the COM port, and we will look at COM port number 1. And under COM port number 1, this is where we can get our IP address from that we are going to be using. So here is my static IP address that we're going to be using, which is 192.168.1.230. We have to know this in order for the simulator to talk to our Click PLC. So once we have that all loaded up, we can close that down, and we'll cancel out of that. And the other thing we need to do is make sure that our Modbus TCP setup is set so that it will use a port 1 as our server or slave unit to our Modbus simulator on our machine simulator from EasyPLC. So here we have, just to ensure that that's checked, it is checked by default, and the default port number is 502. So we'll just hit OK for that. So now that is our settings that we need in order to communicate. Now if we look at the actual program, we can see here that we have our robotic cell start, which is X1, and it will go through our normally closed robotic cell stop, and then we have a robotic cell run command, which is the first output of our actual physical I/O on our hardware. And that seals in here. That allows the unit to actually run. If we cursor down to the next line, we have if it's running and we have the time delay output, then we have a timer set for 500 milliseconds, which has half a second. Next, what we do is we copy indirectly our address DS0 to DS51, or DS area pointed to by DS51, and then sets our output bits to DS56. Now 56 we then use and we spread those outputs out. So we turn on C101 to C116. And when we do that, and then when we don't have that, we don't zero everything out. And how we do that is we actually, instead of zeroing it, we actually will then control the individual bits here to the actual physical outputs that we want to control. So here, if I see 101 is on, and we're running, then this output turns on. So if we stop the conveyor, this turns off. The next one is our stop. It will operate whether we're running or not running. So it maintains the last state when we have the power off or shut the machine off. And then if we look down here, you can see that we have the engine create, and we have the pallet create or light machine 2 visible. When it's running and we have it creating, then we will reset this or stop that or operate it. And when we stop it, if it is on, then it remains on. If it is off, then it remains off. So we don't want to create multiple parts when we stop this line. Then we have the output beacons. So our red light, so we're not running, our red light turns on. We are running, it turns it off, etc. Then we have our yellow and our green. So our green comes on when we run our cell. And then we have our time delay output. Then we have our setting up our inputs themselves. We have a robot cell working. So all of these input switches then go to these input contact coils. And we take those contact coils and we create a word DS40 from that, which is our input word address. Then we take our input word address from our table, and we put that to our input word indirect, which is DS41. So we're going to now compare DS40 to 41 to see what we have to do next. So in this particular one, you can see that we have our robotic cell start. We have our DS40 compared to DS41. And if it's equal, then what we do is we add 1 to our indirect address pointer for our input and our output. You can also see here that when we're not running, we can use input X3 and it will jog our sequence, which basically will then add 1 to our indirect address pointers. And once we do that, we compare our input pointer to the value 106. When it's equal, then we copy 100 back into address DS50 or indirect input pointer, and we copy 200 into DS51, which is our output pointer. We also use the first scan flag that will do the same thing, or a reset input, which is X4. So that is the entire program that we have. Now we've talked about the input table and the output table. We can actually see those input and output tables by taking a look at the address pointer or address picker. So we take a look at the address picker. You can see here there's my X, my inputs here, and my Y, my robotic cell running here. We have our X101. These are the ones that are coming from our machine simulator, and we can take a look at our Modbus address here by clicking here. So it starts at address 100033, and our outputs are starting at address 8225. So there are our Modbus address. And if we go to our DS, now we know that DS100 is our starting of our table, and this is our input table. So you can see here that our initial values are values set to correspond to what we're expecting to see in that input side of things. Then if we look at DS200, you can see here are our initial values starting at DS200. This shows what the output status will be according to the same as what we've seen in our sequence table that we created before. So all this is now programmed in. So what we have to do is we'll just cancel out that, and we have to save our program, and then we have to transfer it over to our PLC. And what we want to do also is ensure that our PLC is actually in run mode. So let's just hit stop first, and we'll stop that. And now we'll hit run, and now our PLC is in run. So that is the development of our Click PLC program, which is step 4. The next step and the final step is testing the program and to make sure it actually operates. So we'll go back to our machine simulator, and what we can do is we'll just hit reset the machine. And when we reset the machine, it goes back to the standard, and you see we have no PLC connection. So in order to test it, we have to connect to our I/O drivers, which are right here. We will select the Modbus driver, and we will configure that Modbus driver. And what you'll see is we're going to use the TCP/IP port. Our address is 192.168.1.230, which is the same as what we just looked at in our Click programming software. Our digital inputs are inputs to the simulator, or outputs from the PLC. We'll start at 8224, and this is offset by 1. And we have 14 of these inputs, or inputs are coming into our simulator. We have now our digital outputs. They start at address, Modbus address 32, which is again offset by 1 that we saw previously. And we have 4 of those outputs. So hit OK. And now what we can do is assign these Modbus addresses to the input points and our driver inputs to our PLC outputs. Or we can just go driver and then automatically assign, which will automatically assign this for us, which saves you a lot of time. Then we'll hit exit. We'll start driver and exit. You can see that everything's correct. We have our driver connected and it's in green right now. We can then view our I/O. And now we're set to actually operate. And remember, we had it in run mode. We can see that our light right now is red. And so what we'll do is go to our Click programming software again. Here we go. And we will actually call up our data view. Call this over here. And there are all our I/O. And we're just going to look at the part of that. And we're going to take the rest of the program here and just move it off the screen for us. We'll call back our simulator here. There we go. And now what we can do is we can actually start this robot cell. robotic cell. There you go. Now we started it. Put this over here. You can see that the engine blocks are coming in. So we pull this off to the side. You can see it, and it picks up the engine. And you can see that when it picks up the engine, our input pointer is pointing to the step that we're on. Puts the engine back down, releases it, lifts up, goes back, and then homes again. And then we have another step. So we can actually turn on the time sequence here, and then speed things up if we wanted to. So one thing that we did say that we could do is actually stop the sequence at any time. So if we were to stop this, and we can stop it anytime by clicking on the stop. So we've stopped the sequence now. Okay, and it stops actually at the input address pointer 102. We can then go on again, and it continues our sequence. The other thing we said we can do is at any time we can actually stop it, and then we can actually jog our sequence. So if we jog it, you can see right now we're at the first step. Step 1, step 2, 3, we put it into the pallet. Now remember, we're not controlling from the input side, so we're just controlling the outputs directly. And this is a great way of testing the actual logic itself. There's 4. And then what we can do is hit reset and reset it back to step 0 again, where we can start this process once again. And you see it picks up exactly where we are. So we can actually test it and make sure that this is exactly what we want to see in our display. And like we said, we can actually speed this up on our time frame just like we did with the demo mode. And this will actually speed that up and allow you to view it. So this is a great way, EasyPLC, the simulator is a great way in learning PLC programming. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.